Solve by completing the square. X squared minus 6x equals 2. I'm going to rewrite this, but I'm going to leave a little bit of extra space after the negative 6x so that we have room to complete the square. So we have x squared minus 6x equals 2. And the problems that we looked at in the previous section had perfect square trinomials on one side. And if we have something that we can write in the form something squared equals a number, then we can use the square root property. So our goal is going to be to complete the square on the left-hand side. Recall that to do this, we need to take the coefficient on the x, which in this case is negative 6, divide it by 2, which in this case is negative 3, and square it, which in this case is 9. So to complete the square, we need to add 9. But because this is an equation, if we want to have an equivalent equation, we're also going to have to add 9 on the right-hand side. So when we're completing the square in these problems, we need to make sure that we're adding the same quantity to both sides. Now that we've completed the square on the left-hand side, we can factor that. X squared minus 6x plus 9 becomes x minus 3 squared. And on the right, we can perform the addition. 2 plus 9 equals 11. And now we have something in the form where we can use the square root property. When we take the square root of the left-hand side, that leaves us with x minus 3, because taking the square root undoes the squaring. And then on the right-hand side, we're going to have plus or minus root 11. Remember, we always need that plus or minus symbol when using the square root property, and the square root of 11 is just root 11. It's not a perfect square, so we can't actually evaluate the square root. Now, one more step to getting x alone is to get rid of that 3. So we're going to add 3 to both sides of the equation. This gives us x on the left-hand side, and 3 plus or minus root 11 on the right-hand side. And this is our final answer. X equals 3 plus or minus the square root of 11.